Define flux density and magnetic field intensity. Name Shyam Kumar, rule number 2195112 first year B section. A vector quantity measuring the strength and direction of the magnetic field around a magnet or an electric current. Magnetic flux density is equal to magnetic field strength times the magnetic permeability in the region in which the field exists. Magnetic flux density. A vector quantity measuring the strength and direction of the magnetic field around magnetic or an electric current. Magnetic flux density is equal to magnetic field strength times the magnetic permeability in the region in which there exist electric charges moving through a magnetic field are subject to a force described by the equation F is equal to Q into B, where Q is the amount of electric charge, V is the velocity of the charge, B is the magnetic flux density at the position of the charge, and X is the vector product. Magnetic flux density also can be understood as the density of magnetic field. A magnetic flux lines of force magnetic flux lines passing through a specific area. It is measured in units of Tesla, also called magnetic flux and magnetic induction. Magnetic field strength. Magnetic field strength, also called magnetic intensity or magnetic field intensity, the part of the magnetic field in a material that arises from an external currents and is not intrinsic to the material itself. It is called expressed vector H and is measured in units of amperes per meter. Magnetic flux density. The magnetic flux density that exists at zero magnetic field strength when a sample of magnetic material has undergone symmetrically cyclical magnetization. From Modern Dictionary of Electrons, 7th edition 1999. Magnetic field density. Magnetic flux density is the amount of magnetic flux through unit area taken perpendicular to direction of magnetic flux. Flux density of B is related to magnetic field of H by B is equal to mu H. It is measured in Webers per square meter, equivalent to Tesla's T. Tesla, the Tesla symbol T, which derived unit of the magnetic B field strength, also magnetic flux density. In the International System of Units, a particle carrying a charge of 1 coulomb and moving perpendicularly through a magnetic field on Tesla at a speed of 1 meter per second experience a force with magnitude 1 Newton according to the Lorentz force law. As an SI derived unit, the Tesla can be also expressed as the last equivalent in SI base units, where A is ampere, C is coulomb, kg is kilogram, m is meter, n is newtons, S is second, H is Henry, V is volt, J is joule, and WB is called Weber. Electric versus magnetic field. In the production of the Lorentz force, the difference between electric fields and magnetic fields is that a force from a magnetic field on a charged particles is generally due to the charged particles movement, while the force impacted by an electric field on a charged particles is not due to the charged particles movement. This may be appreciated by looking at these units for each. The units of electric field, the MKS system of units Newton per coulombs, 1 by C weight, while between the two types of fields meters per seconds, which is velocity. The relationship immediately highlights the fact that whether a static electromagnetic field is seen by as purely magnetic or purely electric or some combination of this is independent upon one's reference frame, that is one's velocity relative of the field. In ferromagnetics, the moment creating the magnetic field is the electron spin, and to a lesser extent electron orbital angular momentum in a current carrying wire. The movement is due to electrons moving through the wire. Unit of magnetic flux. Magnetism is needed a vast chapter for students with a lot of topics and concepts to cover. However, on this page we will discuss the unit of magnetic flux. Well, in simple terms, magnetic flux is defined as a measure of the strength of a magnetic field over a given area. It has the dimensions mass length squared per time squared electric current. It is denoted by Greek letters pi, and a symbol for the magnetic flux is basically used to describe the effects of the magnetic force on something occupying a given area. Now let's look at the magnetic flux units. SI units of magnetic flux. The SI units of magnetic flux is the Weber, WB, a flux density of 1 Weber by m2. 1 Weber per square meter is 1 Tesla. T. Weber is commonly expressed in a multitude of other units. WB, Weber. T is equal to Tesla. V is equal to volt. M is equal to meter. J is equal to joule. S is equal to second. H is equal to Herne. A is equal to ampere. Mx is equal to Maxwell. The unit has also been named after German physics with equal Weber. Definition of magnetic intensity: a vector quantity pertaining to the condition at any point under magnetic influence. Electromagnetic wave, measured by the force exerted in a vacuum upon a free unit north pole placed at the point in question, called also magnetic force. Definition of field intensity: the attribute of a magnetic, electric, gravitational or other field of force that at any point is measured by the force which is field exert upon a unit pole, unit charge of unit mass placed at the point, called also field strength. Magnetization and magnetic intensity. We have all fun with magnets as kids. Some of the youth are now even playing with them. What makes them magnetic through? Why aren't there magnetic fields in all materials and substances? Have you ever given it any thought? The subject of magnetization and magnetic intensity will be covered. Magnetization is caused by magnetic movement as well as now. This is caused by the mobility of electrons in atoms. The response of a substance to an external magnetic field determines its net magnetization. Magnetic field intensity. Magnetic field intensity H at any point in the magnetic field is defined as the force experienced by the unit north pole at the point. In simple terms, it is a measure how strong or weak any magnetic field is. The SI unit of magnetic field intensity ampere by meter. Unit of magnetic field intensity. Magnetic field strength, also called as magnetic intensity or magnetic field intensity. The part of the magnetic field in a material that arises from an external current is H0, not intrinsic to the material itself. It is expressed as the vector H and is measured in units of ampere per meter. Magnetic field strength. Magnetic field. To magnetic field is the area around a magnet in which the effect of magnetism is felt. We use the magnetic field as a tool to describe how the magnetic force is distributed in the space around and within something magnetic in nature. In these articles, let us formalize ourselves with the magnetic field intensity and characteristics. What is magnetic field? Magnetic field is the region around a magnetic material or moving electric charge within which the force of magnetism acts. A magnetic field is a vector field in the neighborhood of a magnet, electric current or charge changing electric field in which magnetic force are observable. A magnetic field is produced by moving electric charges and ensuring a magnetic movements of elementary particles associated with fundamental quantum properly known as spin. Magnetic field and electric field are both interrelated and are components of the electromagnetic force, one of the four fundamental forces of nature. Magnetic intensity. Magnetic field intensity of H at any point in the magnetic field is defined as the force experienced by the unit north pole at that point. In simple terms, it is a measure of how strong or weak any magnetic field is. The SI unit of magnetic field intensity is ampere meter. According to David C. Jelly's magnetic field intensity definition as follows. A magnetic field intensity of strength 1 ampere per meter is produced at the center of a single circular coil of conductor of diameter 1 meter when it carries a current of 1 ampere. The magnetic flux density B is the magnetic moment developed for unit volume of a material when placed a magnetism field. The relation between the magnetic flux density and the magnetic field intensity is given by B is equal to mu h. Sometimes the definition of magnetic flux density and magnetic field intensity can be confusing. Magnetic flux density is the measure of the number of magnetic lines or flux that passes through a point on a surface. It is measured in Tesla and its vector quantity. Apart from units, B and H are the same in a vacuum. The difference between two arises in a magnetic material. Inside a magnetic material, the total magnetic field is the resultant of BO and BM produced due to magnetism. B is equal to BO plus BM is equal to mu H plus mu M. Mu is equal to mu of H plus M. The international system SI unit of field intensity for magnetic field is Tesla of T. 1 Tesla of 1 T is defined as the field intensity generating 1 Newton of force per ampere of current per meter of conductor. What is SI and CGS units of magnetic field intensity? The Tesla symbol T is the derived SI unit of magnetic flux density, which represents the strength of a magnetic field. 1 Tesla represents 1 Weber per square meter. The equivalent and surprised CGS unit in the Gauss. The Tesla symbol T is the derived unit of the magnetic B field strength. Also, magnetic flux density is the symbol international system of units. 1 Tesla is equal to 1 Weber per square meter. Electromagnet. An electromagnet is a type of magnet which the magnetic field is produced by an electric current. Electromagnets usually consist of wire wound into a coil. A current through the wires creates a magnetic field which is concentrated in the hole denoting the center of the coil. The magnetic field disappears when the current is turned off. The wire turns are often wound around a magnetic core made from a ferromagnetic materials such as iron. The magnetic core concentrates the magnetic flux and makes a more powerful magnet. A simple electromagnetic consisting of a coil wire wrapped around an iron core. A core of ferromagnetic material like iron serves to increase the magnetic field created. The strength of magnetic field generated is proportional to the amount of current through the winding. Magnetic field produced by a solenoid coil of wire. The drawing shows a cross section through the center of the coil. The crosses are wires in which current is moving into the page. The dots and are wires in which current is moving out of the page. The main advantage of electromagnetic over a permanent magnet is that the magnetic field can be quickly changed by controlling the amount of electric current in the winding. However, unlike a permanent magnet that needs no power, an electromagnetic require a continuous supply of current to maintain the magnetic field. Electromagnets are widely used as components other electrical devices such as motors, generators, electromechanical solenoids, relays, loudspeakers, hard disk, MRI machines, scientific instruments, and magnetic separation equipment. Electromagnets are also employed in industry for picking up and moving heavy iron objects such as scrap iron or steel. Applications of electromagnets. A portable electromagnet is one designed to just hold material in place. An example is a lifting magnet. A tractive electromagnet applies a force and moves something. Electromagnets are very widely used in electrical and electromechanical devices including Weber. The SI unit of magnetic flux is the Weber, named after German physicist and co-inventor of the telegraph, Wilhelm Weber, and the unit has to symbol WB because the magnetic flux is just a way of expressing the magnetic field in the given area. It can be measured with a magnetometer to in the same way as the magnetic field. Thank you.